Let's work a displacement example. In this example, we're told that Jace walked 4 kilometers north, turned and walked 3 kilometers west, and finally walked 3 kilometers south. We're asked to find his displacement over the entire trip. So this diagram is my crude version of drawing Jace's path. First, he walked 4 kilometers north. I said that north is upwards. Then he turned and walked 3 kilometers west, and finally another 3 kilometers south. Displacement, we know, is defined as final position, which is right here, minus initial position, which is right here. We can draw displacement as a vector or an arrow with a head at his final position and a tail at his initial position. While this is not a triangle, we can actually make this a right triangle by adding a line right here. So now this is a right triangle. We know the length of this side is the same as the length of this side, or 3 kilometers. And the length of this side of the right triangle is just the entire length of this side, 4 kilometers, minus this 3 kilometers, or 1 kilometer. So now we have a right triangle, and if we get rid of all the other mess, it'll be clear. So we're going to get rid of all this other extra stuff besides the right triangle. Here we have it, our right triangle, with sides of 1 kilometer, 3 kilometers, and the hypotenuse is the displacement, or the thing that we're looking to find. So now that we've got a right triangle, we know we can use the Pythagorean theorem, which says a squared plus b squared equals c squared. We know that a and b are just the 2 shorter sides, and c is the hypotenuse. So we can plug in our lengths for our sides a and b. Before I plug into the Pythagorean theorem, I like to go ahead and convert my units if necessary. So notice right here we have 3 kilometers. The proper SI unit for distance is the meter. So we're going to go ahead and convert this from 3 kilometers to 3,000 meters. Same over here. Instead of 1 kilometer, we will convert it to meters. 1 kilometer converted to meters is 1,000 meters. And at this point, we're ready to plug 3,000 meters and 1,000 meters into our Pythagorean theorem and to solve for our hypotenuse, which is c. So for a, I'm going to plug in 3,000 meters. Can't forget to square it. For b, I'm going to plug in 1,000 meters. Again, I must square it. And all of this equals c squared, or the hypotenuse squared. So now all I have to do is simplify the left-hand side of the equation and then finish solving for c. So 3,000 squared is 9,000. 1,000 squared is 3,000 squared is 9 million. Hold on one second. Let me go ahead and show you where I got that. 3,000 squared is 9 million. 9 with 6 zeros after it. The meters are squared. 1,000 squared is 1 million. Again, let me show you where I got that. 1,000 squared, 1 million, 1 with 6 zeros after it. When I add this together, it will be equal to the hypotenuse squared. Remember, the hypotenuse is just what we're looking for. So now I add these together, 9 million, 1 million, 10 million. The meters are still squared. still equal to c squared. We're almost finished. All we have to do to solve for the hypotenuse is to take the square root of both sides of the equal sign. So I need to take the square root of 10 million so 10 million, take the square root of it, and I have 3162.28 meters rounded to 2 decimal places. So 3162.28. Let me double check it. Meters. If you have any questions, make sure you ask them.